Hey, it's Emma, and this video is on network topologies. We'll be looking at two different types of network topologies, bus and star. Firstly, a potentially unfamiliar term is topology, which in this context is the layout, shape, arrangement of a network. There are a lot of synonyms, but it should become clear as we move on. Let's look at our first topology, the bus. In this, all computers or devices are attached to a linear transmission medium called a T-piece, the so-called bus. When a transmission is sent onto the bus, the signal goes along the bus and are received by all the devices or nodes connected to it. Some good points are: it is easy to connect to other computers and requires less cable. However, this cable can be a security issue, as every device receives all transmissions. You have resistive devices called terminators at either end to prevent a signal reverberating up and down. The main problem with a bus topology is the collision between signals when multiple devices try to communicate at the same time. Because there is only one place they can go, along the bus, collisions are inevitable, and it means data gets lost and has to be retransmitted. In a future video, we'll look at the protocol that helps avoid this, but it's still a disadvantage of the bus topology. However, a bus topology is cheap as you don't require much cable, though of course you are heavily reliant on this, so if the cable fails, then so will the whole network. Our second main topology is star, and it gets its name from how we usually show it. But of course, it's about how it's conceptually laid out, rather than how much like a pretty star it looks. In a star, every node is connected to a central node, which could be a server or a device called a switch, which is like a router for a local network. Each node has its own cable to the central node, so whilst this is expensive, few data collisions occur, making the network reliable. Also, if one cable fails, then only that node is affected, not the whole network. Though if the central node fails, then so does the whole network. Each node has its own cable to the central node, so adding or removing a network is easy. So whilst it is expensive, few data collisions occur, making the network far more reliable. Also, if only one cable fails, then only that node is affected, not the whole network. Though if the central node fails, so does the whole network. One last disadvantage is that the cable length is needed. So far, we focus on what you'd describe as the physical topology, i.e. how the cables and nodes are physically laid out. However, a network will also have a logical topology, which is more about the operation and where and how the data moves about. They are independent of each other, so a physical star network can act like a logical bus using a bus protocol and appropriate switching. For example, from a physical perspective, this network looks like a combination of a physical bus and star. However, using an Ethernet protocol for bus networks, and if the central node of the star, the switch, sends the signal to all the devices, then the whole network behaves logically like a bus. Okay, let's recap. A physical bus network is one where all nodes are connected to a single cable called a bus. The main issues are data collisions, and the main advantage is the cost and simplicity. A physical star network revolves around a central device, usually a switch or a server. This requires a lot of cable, but there are fewer issues with collisions, and if a single cable fails, then the network isn't broken, though the central device is very important. Also remember that a physical topology is different to a logical topology, and protocols and certain hardware can be used to convert between the two.